Hello everyone, it's Red Saber here from Saber C++, and today we're going to be learning about the basics of Arduino. I've put a few links in the description so you can get what you need to follow along. Let's get started. To program your Arduino, you'll need to download the free Arduino IDE. I've put a link to the page in the description, and you can simply select the correct version for your OS, click Just Download, and wait for it to download. This is the Arduino IDE, which stands for Integrated Development Environment. This is where we'll write the code that will control our Arduino. There are a few other things we should take a look at though. Up here, this little check mark is the verify button, which will check through our code and make sure everything's working as it should. This is the upload button with a little arrow on it. It'll allow us to actually upload the sketch to our Arduino, but it'll also verify it first to make sure there are no errors in it. This is the board selector, where we can choose which board we'd like to upload our code to. And over here on the right, we have a couple of other tools which we can use to communicate with our Arduino and see what it's doing. We'll get into those a little bit later. Now that we're all set up, grab your Arduino and let's get started. Let's take a look at lighting up LEDs with our Arduino. We'll need our Arduino board, a breadboard, an LED, a couple of jumper cables, and a resistor. First, let's connect our LED to the breadboard, taking note of which leg is longer, as this is the positive side. Next, let's connect a wire from that positive side to the 5-volt pin on our Arduino. Then, let's take this resistor and connect it from the other leg of our LED to any of the pins on this blue strip here. All of them are connected, so we can take a wire from any of the other ones and connect it to a ground port on our Arduino, labeled GND. Now, our LED lights up. This is nice, but what if we want to change it so our Arduino can control the LED? Well, we'll rewire it by moving the positive wire from the 5-volt pin to pin 0. All of the numbered pins can be controlled by our Arduino, so we'll be able to write a short program to make the LED blink. Here we are in the Arduino IDE. First thing I'll do is create a variable up above everything, which I'll call green LED pin. I'll set this to 0 because it's holding the value of the port we connected the green LED pin's positive wire to. This will allow us to tell the Arduino to turn that green LED on and off in our code. The next area we need to take a look at is the setup function. Here, I'll set the pin mode of the green LED pin to output, because that's what we'll be using the green LED for. The last area to take a look at is the loop function. As it says, it'll run over and over again as long as the Arduino is on. First, let's turn the green LED on. As it's connected to one of the digital pins on the Arduino, we'll use the digital write function. In the digital write function, we'll tell it that we're using the green LED pin, and then we'll tell it to set it to high, which means on. We can also use the digital write function to set the green LED pin to low, which means that it will turn off. Between these two statements, let's tell the Arduino to wait for a second so that we can see the LED turn on and off. We'll use the delay function, which takes in a number of milliseconds or thousandths of a second, and we'll put in 1000 milliseconds, which is 1 second. After we turn the LED off, we'll want to make it wait for a second so that we can see it off before it turns back on. And that's all there is to it. Make sure your board is connected and upload your code. And as you can see, our LED turns on and off every second. Let's add a couple more LEDs to make this more interesting. I'm just going to move this black wire out of the way so that we have room to put in our LEDs. Let's add our LEDs. Here I'm adding a yellow one and a red one, like a stoplight. I'm making sure all of the longer leads on the LEDs are to the right, so that we know which side to connect the positive and negative to. Next, I'll add a resistor from the negative side of each LED to the blue line here. And lastly, I'll add a wire coming from the positive side of each of these LEDs and going to a port on our Arduino. I'll connect the yellow one to port 1 and the red one to port 2. Let's head over to the computer and we can adjust our program to use all 3 LEDs. Let's start by adding 2 more variables. Yellow LED pin, which I'll set to 1 as that's where the yellow LED is connected, and red LED pin, which I'll set to 2 as that's where the red LED is connected. Both of these LEDs will be used for output, so I'll set the pin mode of each of them to output. Perfect. In the loop function, let's make it cycle through our LEDs, turning off the ones we don't want and only turning on the one we do want. At the start of the loop, we'll turn the green LED on, and we'll turn the yellow and red LEDs off by setting them to low. Let's change the delay length so we wait for 2 seconds, so that the green is a little bit longer. In the next section, we'll set the green LED pin off, the yellow LED pin on, and the red LED pin still off. Let's only wait for half a second this time, as the yellow should be shorter than the others. Next, we'll keep the green LED off, we'll turn the yellow LED off, and we'll turn the red LED on. Once again, we can't forget to add another delay at the end of the loop function to make sure that we wait with the red LED on before we start it over and turn the red one off and the green one back on. And that's all there is to it. Make sure your board is connected and upload your code. There you go. You can see our stoplight is working as planned. Now let's take a look at using buttons with our Arduino board. First, I'm going to put this button on the breadboard, making sure that it spans the gap in the center, so that the leads don't connect to each other. Next, I'll connect a wire from one of the ground pins on the Arduino to the blue line on the breadboard. Next, I'll take a resistor and connect it from the blue line on the breadboard to the right side of the button. Then, I'll take a wire and connect it from the 5-volt pin on the Arduino to the right side of the button. To read the signal from the button, I'll run a wire from the back right side of the button to port 0 on the Arduino. When the button is up, no power will flow through the button because it's connected to the ground line. When the button is down, power will flow from the 5-volt pin through to the 0 pin, letting us know that the button is pressed. Next, let's connect an LED so we can turn it on and off. I'll slide the LED into the breadboard and connect a resistor from the shorter lead to the blue line on the breadboard, which is connected to the ground pin on the Arduino. Then I'll connect a wire from port 1 on the Arduino to the other lead of the LED, allowing us to turn the LED on and off with our program. Let's get started. First, I'll create 2 variables. One for the white LED pin, which I'll set to 1, and another for the button pin, which I'll set to 0. In the setup function, I'll set the pin mode of the white LED pin to output, but I'll set the pin mode of the button pin to input, as we'll be reading from the button pin to determine if it's pressed or unpressed. In the loop function, we'll need to check if the button is pressed or not. In the loop function, we'll add an if statement, which is written like this. If, parentheses with a condition inside them, then braces with actions inside of them. So if whatever is in here evaluates to true, then we'll do whatever is in here. and this could be as many lines long as we want. So, what we want to check is if the button is pressed. To do that, we'll need to use a new function called digital read. As we're on a digital port, we need to use the digital read function on the button pin, and it'll give us an output which we can check if it's equal to high. We could also check if it's equal to low, which would mean that the button isn't pressed. But in this case, we want to determine if the button is pressed, so we'll check if it's high. That means the button is down and electricity is flowing through it. If it is, then we'll use the digital write function on the white LED pin and set it to high as well. Outside of the if statement, we could either add another if statement checking if the button pin is low, or we can use the else keyword. This means that if this part up here isn't true, we'll do this part down here. So if the button isn't pressed, then we'll turn the LED off by using digital write to the white LED pin and setting it to low. And that's all we need to do. Now when we press our button down, the LED will turn on. And when we let it go, it'll turn off. Make sure your Arduino is connected and upload your code. And as you can see, it works perfectly. When we press down the button, it turns on the LED. But what if we don't want to have to hold down the button? Let's adjust our program so that we can just tap the button to turn on the LED. In order to check if the button has just been pressed down, we need to know whether it was up before. The button was up the last time we checked, and now it's down. That means the button was just pressed. So we'll create two more variables. The first will be called button is up. You'll notice I set it to type bool instead of int. This is because it only needs to have one of two values, either false if the button isn't up, or true if the button is up, which is how the program starts. We'll create another variable of type bool, and this one will be called light is on. We'll set it to false because the light is off at the start. We haven't added any other buttons or LEDs, so we don't need to change the setup function at all. Let's hop down to the loop function and change our runtime logic. Instead of just checking if the button is pressed, we need to check if the button is pressed and, that's what these two ampersand symbols are for, the button was up the last time we checked. So if the button's down now and it was up, then we know it's just been pressed. First thing we need to do, if this is the case, is say that the button is no longer up by setting the button is up false, because the button is down now. Then we need to check if the LED is on. So we'll do if light is on, and if the light is on, then we need to turn the light off. So we'll set light is on to false, and we'll write to the LED that it should turn off. Otherwise, else, meaning that light is on is false, we'll set light is on to true, and we'll turn the LED on. So the first thing we check is if the button's pressed and it wasn't the last time we checked. If that's the case, then we need to make sure to set that the button is pressed, so we don't just keep triggering this. And then, if the light is on, we'll turn it off, and we'll let our program know that it's off by setting the light is on variable to false. If the light is off, then we'll turn it on, and we'll let our program know that the light is on now by setting this variable to true. The last thing we need to do is remove this section here, and then check if the button pin is up. If the button pin is up, then that means that we should set button is up to true. If we miss this step, then we'd only be able to press the button once, because then button is up would remain false for the rest of the program. So we need to make sure to set button is up to true as soon as the button is deactivated, which means that it's up. That's all we need to do. Connect your Arduino and upload your code. Speaking of buttons, if this video has been helpful to you so far, please tap the like button. And there we go. Now we can toggle our LED on and off with our button. Let's take a look at using potentiometers with our Arduino board. This is a potentiometer. We're going to supply power to it on the rightmost or bottommost pin, and then read the value from the middle pin, which will tell us how the dial is rotated and allow us to change the brightness of an LED. First, we'll supply power to the pin on the right or bottom by connecting a wire from the 5-volt pin on the Arduino. Next, we'll connect a wire from the middle of the potentiometer to port A0, which will allow us to read where the dial is located and use that in our program. The last thing we need to do is connect a wire from the remaining pin on the potentiometer to one of the ground pins on the Arduino. This makes sure that when the dial is rotated away from the positive pin, the LED won't light up. I'll add an LED to the breadboard, once again making sure that the longer positive pin is on the right side. Then I'll connect a resistor from the shorter pin to the blue negative line on the breadboard. I'll connect a wire from that blue negative line to one of the ground ports on the Arduino, and then I'll connect a wire from the positive line of the LED to port A1 on the Arduino. Once again, let's start by creating two variables. The first we'll call potentiometer pin, and we'll set it to A0 because, as you'll remember, we connected it to port A0. The next we'll call blue LED pin, and we'll set this to A1. We'll set the pin mode on each of these. The potentiometer pin will be input, as we'll be reading the value of the potentiometer. The blue LED pin, on the other hand, will be output, as we'll be changing the LED's brightness. In the loop function, let's create a temporary variable called potentiometer value and set this to the value we get from the potentiometer pin. Now, the potentiometer pin is an analog pin, so we'll need to use the analog read function on the potentiometer pin. Now, the potentiometer pin gives us a value between 0 and 1023. So, whereas the LED Now the potentiometer gives us a value between 0 and 1023, whereas the LED only takes a value between 0 and 255. So in order to change the range from 0 to 1023 to 0 to 255, we'll need to divide it by 4. The blue LED pin is connected to another analog pin, so we'll need to use the analog write function again, and we'll use it to set the blue LED pin to the potentiometer value divided by 4. And that's all there is to it. Don't forget to make sure your Arduino is connected and upload your code. And there we go. It's working just as it should, and we're able to change the brightness of the LED with the potentiometer. Let's make our circuit a little more complex by adding a few more LEDs and then using the potentiometer to switch between them. I'm going to add 3 more LEDs, making sure to keep the positive side of each LED to the right, so that I can easily tell when I'm making my connections. Then, I'll connect resistors from the negative side of each LED to the blue negative line on the breadboard. With that done, I'll connect a wire from the positive side of each LED to some ports on my Arduino. I'll start with port 12 and work my way back to 11, then 10. There we go. Now all of our LEDs are wired up and ready to go. Up at the top, let's change this blue LED pin's name to LED pin 1. Next, we'll add 3 more LED pins, LED pin 2, 3, and 4, and we'll set them to ports 10, 11, and 12, just like we wired them up. Then we'll need to set the pin mode of each one to output. Because these lines are so similar, I'll just copy and paste this a few times, and then change the numbers in each function. Now all of our LED pins are set to output. Remember that the potentiometer gives us a value from 0 to 1023. So we'll create an if statement with 4 different sections, each of which will correspond to a quarter of that range, and we'll turn on one of our LEDs. The first section we'll check is if the potentiometer value is greater than or equal to 0, and, with 2 ampersands, the potentiometer value is less than 255. 255 is a quarter of the potentiometer's range, so effectively this checks if the potentiometer is in the bottom quarter of its rotations. If this is the case, then we'll turn LED pin 1 on using the digital write function, and we'll turn all of the other pins off using the digital write function. It's important to note here that while we can use the digital write function to write digital values to one of the analog ports, we can't use the analog write function to write analog values to one of the digital ports. Next, we'll add an else if statement, which is basically an if statement, but it gets ignored if this one is true. In this case, we want that because these two can't be true at the same time, so we might as well ignore this second part if the first part is true. In this else if statement, we'll be checking if the potentiometer value is greater than or equal to 255, because we checked if it was less than 255 last time, and if the potentiometer value is less than 512, which is half of 1023, roughly. Let's copy over this section here, only this time we'll set LED pin 1 to low, LED pin 2 to high, and these other two will remain low. We need another else if statement, which will check from 512 to 768. I'll copy this entire else if statement and paste it down below. We're checking if it's greater than or equal to 512, because here we checked if it was less than 512, and we're checking if it's less than 768. Here, we're setting all of the LEDs to low, except for the pin 3, which we'll be setting to high. And for our last section, we can simply use an else statement, because these cover all of the values except from 768 to 1023. So if we're in at any value other than the ones we've already selected, we know we're in the top quarter of the potentiometer's range. And we can simply set the fourth LED to high and the other LEDs to low. There we go. Don't forget to connect your Arduino and upload your code. And as you can see, when we rotate the potentiometer, the Arduino switches which LED is on. This is just scratching the surface of what you can do with Arduino. If you'd like to learn more, check out my channel, Saber C++. Thanks for watching.